everyone look up for a minute. This is 22 on the white. If you haven't done it yet, that's okay, but I would still watch this discussion. There will be a question or two on the test that will require you to remember the concepts used in this problem. This one tends to be a bit challenging for people. I had a student send me an email and mentioned that she was able to get through all of the white problems except for this one and one other. So here's what I would be recognizing. First of all, whenever they ask me to find constants, I force myself to not look for the constant. Like, you need to focus on something else. You shouldn't focus on trying to find C and D. So don't do that. You're going to focus on other things and you'll just end up finding C and D. It says if f is differentiable at x equal 2, so that's what I'm going to focus on. So all of you need to have, if you don't have one, just raise your hand, I'll bring you some. You need to have a flashcard, several actually. One of my flashcards is this. F is continuous. If F has no jumps, removable discontinuities, or vertical asymptotes. That's one card. That card is the one I use whenever I have a graphical problem. If it's something like this where I don't have a graph, instead of using this flashcard, I use this one. F is continuous at some point, like we'll use this example, x equal 2. So that's the front of my card. The back of my card says the limit as x approaches 2 from the left of the function must be exactly the same as the value of the function itself at x equal 2. Must be the same as the limit as x approaches 2 from the right. So I use the blue flashcard if it's a graphical problem. I use the purple if it's not graphical. If you don't have these two flashcards in your deck, you will be in trouble when you take the test because you'll encounter something like this and your brain will just not have any clue where to go. If you need a flashcard, raise your hand, I'll bring you some. There we go. Go. Why not? Anything else in this? So while you're writing that down, the other two flashcards I have, because continuity and differentiability are related, I have another card that's for graphical problems that says f is differentiable. First of all, f must be continuous. And then f has no corners or vertical tangents. So the key thing there is you never check for differentiability until you've already checked for continuity, because there's no sense checking for differentiability if the function's not continuous. Chance for me to catch up on the cards. Then, if I have a non-graphical problem like the one on the board, I have the other definition for differentiability. f is differentiable at a specific point, only if f is first continuous, and there's no reason to check further if f is not continuous, and then you check the limit as x approaches 2 from the left of f prime, the value of f prime itself at 2, and finally the limit as x approaches 2 from the right of f prime. Question? Yeah, please.
Sorry, I just missed it when I was writing down. So when it says f has no c or vt, what does that mean?
Oh, perfect. Corner and vertical tangent.
Okay.
Don't do question mark it. So, when I read the problem, this is what came to my mind right here. This flashcard. But because the first item on the flashcard is this, that brought to mind this flashcard. And I said, I know I'm not supposed to focus on C and D, so perhaps what I should focus on is, it says the function's got to be continuous. That means these three here have to be the same. So let me go find these three. So we'll pay extra credit here. Raise your hand and tell me what's the limit of f as x gets close to 2 from the left. So show me your hands if you know the value of that limit, as I paint it all in. You've got to have a few more hands than that. So here's our function. Limit means when the x-coordinate is infinitesimally less than 2, the value of f will be what? That's what limit is asking. I'm hoping for a few more hands. We're not going to find a number because the formula for f is in terms of two values we don't know. We don't know C and D, so we're not going to find some numeric value here. It's going to be some sort of expression. There we go. Let's go with Daniel.
2c plus d.
So when x is just a little bit less than 2, I have to look here. So I'm just thinking, okay, so I plug in a value that's a little less than 2. I'm going to get infinitesimally close to 2c plus d. Show me your hands if you do that. 2.3 for Daniel. That's got to equal f of 2. So hands up. What's f of 2? One morning, I was helping somebody yesterday, and they were doing steps that have worked to solve problems that look kind of like this, but they weren't using this definition. And on this problem they were working, they were of course running into an AP trap. So make sure you're using the definition. So what's f of 2? Let's go, Joey.
2c plus d.
Same thing again. We knew it. 2 more. 3 for Joey. You would have a question. Cool. Last limit, hands up. Let's go China.
4 minus 2.
So now China says, hey, x is infinitesimally more than 2, so I have to use this. So that means I'm going to get 4, subtract 2c. This class is all about using the equal sign to our advantage. So now we have an equation that relates c and d. Trouble is, one equation, 2 unknowns, I can't really solve that. So how many knew this one here that China just mentioned? 2.3 for China. Do you have anything about this that they're going, it's bothering them? Don't memorize the process, memorize the idea. Like we're just paying attention to what it means for f to be differentiable. Please, Lexi.
So if the question asks, what's the limit of as x approaches 2, but not from the left or right, just as it approaches 2, would it be the 2c plus d, or would there not be one, because not all three of them are the same?
Awesome. Hold on. That's a really good question. What Lexi is remembering is that when we are finding a limit, the only way to find the overall limit, so what Lexi asked about was, okay, wait a minute. We're finding a limit as x approaches a. The only way to find this limit is to check the left and right limits and compare them. That's what you're thinking, right? And so Lexi's saying, well, wait a minute. This left limit does not appear to be the same as the right limit. So what would I write as this limit? What's weird is, because they tell us that f is differentiable at x equal 2, they're telling us f is continuous at x equal 2. Therefore, they're telling us that these two limits really are identical. But at this moment, I would have no way of writing what this should be. Because until I know values for c and d, there really is no way to write what that is. So they're not going to ask that because of the confusion you're recognizing, Lexi, of like, well, am I supposed to put 2c plus d or 4 minus 2c? Technically, either one would be correct because those two have to be the same. I hope at all.
Yeah, but also, I'll just look through the problems that I was working through in the other packet, but there was one where the left and right limits weren't the same, and so it was like the true or false, and then it was saying like the limit of as x approaches 2 is this. But I'll just ask you after class.
No, I'm going to try one more time because I'm hoping this will help. The difference between this problem, the one you're thinking of, is in the other problem, they're asking you to find this limit. They're not telling you the function is continuous or not. They're just saying, go find that limit. So when you found left and right that were different, you absolutely had to declare that this limit was non-existent on that other problem. Because if the two limits are different, that limit has to be non-existent. Here, kind of weird, the two limits actually are the same. We just don't know what numeric value the limit has because we don't know c and d yet. Does that help a little more?
Yeah.
No, very good. Anybody else? Okay, so I've got one equation, but one equation with two unknowns is not solvable typically. So I want to keep using the information I know, which is I've got to go verify this now. So to verify that, I need an equation for f prime. Finding f prime isn't difficult. I can use this to find f prime. So f prime is going to equal, I take the derivative of cx plus d, remembering that c and d are constants. So hands up, who knows the derivative of cx plus d? Don't overthink it. It's no different than finding the derivative of like 5x plus 10 or 3x minus 7. What would be the derivative of cx plus d? So what's your answer? Just c, because the derivative of cx would just be c alone, just like the derivative of 2x is 2. Then the derivative of d all by itself is 0. Somebody knew it. Points 3 for trips. We need to talk more about that. So that's valid whenever x is less than 2. Please remember, when you're finding the derivative of a piecewise function, don't put the equal sign until you're confident that the function you are differentiating actually is differentiable. So you want to leave that equal sign off. Get it to back up. There we go. Until you're sure the function is differentiable. They tell us this function is, so it's okay to put the equal sign. If you're not sure whether it is or not, don't put it yet. So, please.
Wait, why are we finding the derivative if they tell us that it's differentiable?
Oh, I'm trying to find C and D. So the question was, why are we finding f prime? We already know the function is differentiable. We don't really need a test for it. It's very common on the AP test to give questions in two directions. One way is the way that Lexi brought up, where they say, go find a limit, or go show that something is differentiable. The other way is to do it backwards. They tell you the function is already differentiable, and they ask you to go find some values that make that a true statement. So it's like the process is the same, it's just for a different purpose. So I already know this is true. But I'm going to use the fact that it's true to help me find C and D, to find the values of C and D that will make it true. Does that help very much?
Yeah.
Okay. 2 for Liv. I need the derivative of this. Hands up. What's the derivative of x squared minus cx? It's the same idea of doing the derivative of x squared minus 5x. So what would be the derivative of that, Abby?
2x minus c.
Show me your hands if you knew that. Perfect. 2 points, 3 for Abby. So now I just go find the limit of f prime as x approaches 2 from the left. So show me your hands. Who knows the value of that limit? Limit of f prime as x approaches 2 from the left. There we go. Jensen?
2.
The mistake you're making is are you looking here?
Oh, are we not looking at the derivative anymore?
Are you looking here?
Yeah.
So that's the right place. Are you looking top row or bottom row?
Oh. Would it be 4 minus c? Wait, I'm getting this wrong.
True.
It is?
No, you're getting it wrong.
Yeah.
Sorry.
No, you're good.
Let's just keep talking until it clicks. So don't just do the steps again. Make sure this makes sense. You're looking here at f prime because we're finding the limit of f prime. Are you looking top row or bottom row?
I was looking top row.
Good. That's correct because we're picking a value of x is slightly less than 2. But what this is telling you is,
Oh, it's a constant.
it's a constant.
My bad. It's c.
See, that makes sense?
Yeah.
Don't worry. Yeah, that's saying that the slope of f, like this is telling you, the slope of f at all x coordinates that are less than or equal to 2, the slope of f will just be whatever the value c is. So c turns out to be 7, the slope's 7. Nothing else. How many knew it? 0.3 for Jensen. F prime of 2 would be the same. Hands up for the limit as x approaches 2 from the right. Hands up. What's the limit of f prime as x approaches 2 from the right? Let's go, Emma.
4 minus c.
So now Emma's looking here. If x is slightly bigger than 2, we'll get 4 subtract c. How many do it? 0.3 for Emma. So now we have another equation. This equation is more useful because it's an equation with one unknown. It's an equation with one unknown. So you can figure out the value of c. Please raise your hand if you have been able to look at that equation and determine the value of c. A few more. What is the value of c given that c must equal 4 minus c? You don't need to solve it in your head, just use algebra and solve it. China?
C equals 2.
How many knew it? 0.3 for China. Do you need to talk about it? So hands up if you know what to do now. Now where do we go? Let's go Parker.
Oh, we know that c equals 2, so we take c and plug it back into the equation that we already have and find e.
yeah, we go back to this equation we first found, and we note that 2, C is a value of 2, plus D must equal 4 minus 2 times 2. So this is, and it's kind of glitching, 4 plus D must equal 4 minus 4, which is 0. Therefore, Parker, what's the value of D? Gosh. Just look at this.
4. Negative 4.
Negative 4. So back to 2 for Parker. Back to Lexi's comment about the limits. What we actually figure out from all that, Lexi, is that now we know the values of C and D. We could say, oh yeah, okay, so 2C plus, or this one's a little quicker, 4 minus 2C is actually 0. So this limit is actually 0. Because the left and right limits were the same. We just didn't know that, so there's no way for us to say it. But again, that's different than the problem you were asking about. The problem you're asking about, they actually said, go determine the limit. So anyways, questions? Please.
When I did it the first time, I just looked at the bottom, and since I knew that it was continuous, I knew it was going to map up, because it told us that it was differentiable. And so I just looked at the bottom and got 4 minus C times X, and I just figured out that from that C equals 2. And then I plugged in that at the top.
Say it one more time.
Does that work?
So you use the answers.
No.
No.
I knew that it was approaching at X equals 2, and so I plugged in 2 for X for the bottom equation and just found that.
So you have got like 4 minus 2C.
Yeah. And then is that like strong thinking?
I think you lucked out.
Really? Okay.
Yeah, I think you got lucky, which happens. I don't see any logic for where you're going, to be honest.
Okay, then never mind.
There's no reason. Yeah, I think you're thinking it's 0, and that just turned out to be fortunate.
Okay.
Yeah, it wouldn't have to equal 0.
Okay.
Yeah, actually, Tyler's seeing it. Because it turned out to equal 0, that actually
Then
worked.
that's why it worked, but okay.
Yeah, that you wouldn't want to count on that.